How do you do, my friends everywhere, boys and girls and ladies and gentlemen and men and women and people? I am Professor Julius Sumner Miller, and my business is physics. But I will depart for a moment from that adventure to talk about some beautiful mathematics. The mathematics of the cone, the right circular cone. In an earlier exercise, we explored the motion of a double cone on a certain track. This is said to be a cone of two naps, N-A-P-P-E-S. Here is a cone of one nap, a right circular cone. Here I draw it. Whoop. Oh, that was an interesting exercise. Notice no chalk came off on the board. Answer, not enough friction. You see, without friction, we could not write. Without friction, we could not walk. Without friction, I could not stop. Friction, incredible. So I have to be diverted and say something about friction. We can't get along with it, and we can't get along without it. Millions of dollars are spent in minimizing, reducing friction, bearings and oil and such. But notice the consequence. If we were able to rid ourselves completely of friction, no motion would be possible. The ships in the docks could never get started, and those on the sea could never stop. If you were now to eliminate friction between the soles of my shoes and the floor, I could not get started because I have to push on the earth. There is a way, of course, I could move, and that's up like this. About that I'll speak later. So you see, friction. But anyway, here is the right circular cone. Now, if this cone is cut in certain ways across that long axis, or like that, and other ways, certain conic sections emerge, arise, and we are indebted to this mathematics, for this mathematics, to René Descartes. I want to show you two stamps which commemorate him. Let us take a look at them. Two stamps which commemorate René Descartes. And you would ask me, Professor, why in this array of stamps which commemorate men and events of science, why do you have two? Interesting. One of them is engraved de cours sur la méthode, and the other de cours de la méthode. And the engraver of one of them, you see, made a mistake in the French grammar. Discourse on Method, 16 and 37. So now let us look. Oh, yes, I have it marked. What did René Descartes say? I have often wished that I were equal to some others in promptitude of thought, or in clearness and distinctness of imagination, or in fullness and readiness of memory. Isn't that terrific? So let us look at a dissectable right circular cone. If it is cut off across the top like so, we get a circle. If it is cut off obliquely to the axis like so, we get an ellipse. If we cut it off in this fashion, we get a parabola. If we cut it off in this fashion, we get one part of an hyperbola. And these conic sections can all come out of one equation. Let me write it. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Can you imagine one equation embracing all of this, which tells us the orbits of the planets, the orbits of electrons in atoms, and the paths of projectiles, and such other mysterious things, all from the consideration of a right circular cone. And I thank you for watching.